Hey everyone, welcome back to The Explainer. Today, we are tackling what is arguably the absolute biggest bottleneck in artificial intelligence right now. We're going to break down exactly how we can build an ironclad architectural defense to actually trust AI again, because let's face it, we need to. But at the end of this, you're going to know exactly how to secure these systems. Okay, let's dive into this. 48%. Recent diagnostic logs, like those from the Vortex systems, have revealed a genuinely shocking truth. The more complex an AI model becomes, the more it can actually sneak false facts right into its answers. Under certain complex reasoning conditions, these models hallucinate up to 48% of the time. That means almost half the time, an AI might just hand you false answers, fake citations, completely fabricated data. And it does it all with absolute convincing confidence. It's a massive problem. So, to fix this, we really need to understand what's actually happening under the hood. What we all casually call a hallucination is actually more accurately termed confabulation. It's this phenomenon where an AI seamlessly weaves fiction right into fact. You can think of it like a critical disease within the system. It literally turns this wildly helpful tool into a massive liability. And it typically happens when the AI is forced to rely purely on its own internal stochastic memory to do complex reasoning. It doesn't actually know the answer, so it mathematically guesses one. To cure this disease, we've got to stop treating it with simple prompting tricks, We need a targeted cure. Defense Layer 1, RAG and mandatory citations. This is the first of our 5 multi-layered architectural solutions to help us move way beyond simple prompting. And this brilliantly illustrates how we start building that fortress defense. This is the core shift for Layer 1. We absolutely have to decouple the AI's reasoning engine from its flawed internal data. Relying purely on internal weights and stochastic memory, well, that's exactly what leads to confabulation in the first place. Instead, the model must be forbidden from answering from its raw training data. We replace that instinct with an external source of truth, forcing the system to query a verified vector database, like Pinecone, Milvus, or Weaviate, which contains only trusted, pre-approved documents. But here's the thing. Just querying a database isn't enough on its own. We need strict verification. Enter the 0.95 threshold. Inside this first defense layer, there's an internal critic engine running. Its entire job is to rigorously cross-check the AI's output string against the retrieved source chunk from the database. It basically asks, hey, did you actually pull this from the text? And if the match probability drops below 0.95, the answer is immediately discarded. It is a ruthless, highly effective filter. All right, moving on to Defense Layer 2, the Multi-Agent Critic Protocol. So, directing your attention to the breakdown, single-stream AI models, models just operating all by themselves, often suffer from this kind of sunk cost logic. Basically, if they make a tiny error early in their thought process, they stubbornly commit to it and defend it to the bitter end, which creates a massive confabulation. We solve this by deploying an internal courtroom drama. Agent A is the generator, it produces the initial answer, but right next to it is Agent B, the adversary. Agent B's sole purpose in life is to aggressively hunt for inaccuracies, logical fallacies, and fake citations in Agent A's work. Finally, Agent C acts as the judge. It will only synthesize the final response if A and B can reach a verified agreement. This drastically reduces hallucination rates by forcing the AI to argue with itself before it ever even talks to you. Which brings us to Defense Layer 3, Temperature Zero and strict decoding. Now, in AI terms, temperature controls creativity. But here's the catch. High creativity settings actively increase the danger of the system selecting lower weight, fabricated tokens. If you want a strictly factual answer, creativity is actually your enemy. So for factual tasks, we lock the temperature to exactly 0.0, no exceptions. We are actively choosing to sacrifice the AI's personality, its conversational flair, and its unpredictability in exchange for rigorous, cold, hard accuracy. At 0.0, the model stops trying to be inventive and starts being purely analytical. So the crucial point is this golden rule. Always pick the most mathematically probable next token. This is a process known as deterministic greedy decoding. By forcing the model to take the greediest, most obvious mathematical path at every single step, we create a rigid, unbending adherence to the most likely factual paths. It leaves absolutely no room for the AI to take a creative detour into confabulation territory. Defense Layer 4, Self-Consistency and Chain of Verification, or COVE for short. This effectively forces the AI to step up to the chalkboard and show its math in public view before handing over an answer. Let's move to and see how this builds on our previous safeguards. Step 1, the model generates a baseline response. Step 2, we prompt it to actively identify the factual claims it just made. Step 3, it must independently verify each of those claims against the provided context. And finally, Step 4, it generates a corrected response based purely on that verification. It's essentially an automated system of the AI grading its own homework, identifying its own assumptions, and utilizing recursive self-correction to guarantee accuracy before you ever read a single word. And finally, Defense Layer 5, Logic Bias and Token Filtering. This final architectural layer analyzes the logarithmic probabilities, or log-probs, of highly specific tokens like names or dates. This is where we get incredibly granular. If the model's internal mathematical confidence in generating a specific token drops below a designated threshold, say -0.5, the system intervenes. It doesn't just guess and hope for the best. Instead, crossing this threshold automatically triggers a warning to the user, or even better, it forces the system to pause and execute a real-time web search to verify that specific token before continuing. It's a hyper-focused safety net that catches the exact moments the AI starts to doubt its own memory. The Vortex Verdict, from Oracle to Librarian. This is the fundamental shift in how we need to view and interact with reliable AI. Now, what's really interesting about this slide is how perfectly it captures our paradigm shift. We've built the 5 layers: RAG, multi-agent debate, temperature zero, chain of verification, and token filtering. But for years, we've treated AI like an oracle, asking it questions out of the blue, relying entirely on its zero-shot reasoning, and just expecting it to know things from memory. And as we've learned, oracles make things up 48% of the time. To stop the confabulations, we must stop treating AI as an all-knowing oracle and treat it as a meticulous librarian. A librarian doesn't guess. A librarian is verifiable, logical, and most importantly, a librarian shows you exactly which shelf they pulled the book from. Which leaves us with this crucial, provocative question to end on. Do you wish to execute a diagnostic on your own AI pipelines? Think about it. Are you treating your enterprise models like oracles, or have you actually implemented the architectural defenses to turn them into reliable librarians? I highly challenge you to take these 5 librarian-style defenses we've mapped out today and apply them to secure your own AI deployments. Let's not settle for hallucinations anymore. Demand the verified truth. Thanks for joining me on this explainer, and keep learning.